Hello and welcome to the first Royal Astronomical Society public lecture of 2021. We're still online and we will be until at least May 2021 when this public lecture series concludes. The Society was founded in 1820 and has been advocating for astronomy, geophysics and space science ever since. I'm Annie, RAS Membership Officer, and it would be remiss of me not to mention our Friends of the RAS Membership Programme. Friends have access to 6 to 8 additional talks like this every year, as well as discounted rates on our astronomy and geophysics magazine and, pandemic permitting, use of our incredible historic library. Membership is £40 for the year. Please visit the RAS website for more information. Anyway, back to the main event. I'm honoured to introduce today's speaker, my amazing colleague, RAS Outreach Education and Events Officer, Lucinda Offer, who will speak with us about the renewed interest in human exploration and settlement on Mars. Lucinda has worked with the Mars Society for almost 20 years and has been their executive director since 2009. More recently, she's been looking to create an education outreach team for them. Formerly a NASA associate with the NASA Spaceward Bound team, whose mission is to put teachers in the field with scientists, Lucinda worked on 4 expeditions around the world, including Mars and Titan analogues in Abu Dhabi, geothermal vents in New Zealand, and tardigrades in the Mojave Desert. Aside from teaching GCC astronomy and leading the public lecture programme as part of her role with the RAS, Lucinda has been a principal organiser for several Mars events and programmes, including at the National Astronomy Week UK 2020 and European Mars Conference 2019. A quick reminder that there will be a Q&A after the talk, so please get your questions ready. There are places to post your questions for our speaker if you've joined us on Zoom in the Q&A box and on YouTube in the chat box. Thank you so much, Lucinda, for joining us today. Over to you.
Thank you so much, Annie, and to Louise, both my colleagues at RIS, for being with me today on this talk. Normally, I'm the one hosting these events, so it's kind of weird to be on the other side and to be giving a talk. I'm really excited to share with you. And Annie mentioned a renewed interest in humans to Mars, because probably in all honest truth, it's never really left us since we started our human space program on a large scale, such as the Apollo mission. So I'm going to talk about paving a path for the human exploration and settlement of Mars. So I'm going to move on. Let's see if I can actually, there we go, yay! So what to expect from today's talk, a bit about me and my work, and I'm going to have to go quicker now. A little bit about history and how we got inspired about humans to Mars. I want to talk about the Mars Underground, which is kind of how this got started, just by students at school, the case for Mars, Mars Direct, all these different things, political landscape, some key missions that we're going to go so far that we've been going through in the last 20 years. Private space in China. I have been doing some Mars education work in China. It's really a huge, they're moving the whole population towards a push for Mars and space, human space exploration. It's actually quite exciting in China. And what will Mars look like in our future? So you know who I am. I just want to focus on the first 2, that I'm the executive director and I've worked at NASA Ames. And this is a picture of me at our Mars Desert Research Station. Mars Society and NASA sent me out to be a teleroboticist. And that's a $25,000 kit right there of a rover that I deployed at MDRS. It was rover Sandstorm, excuse me. And we also had 2 other rovers. It was a NASA Google Mars Society project. So we get our chapters involved in doing things like this. We delivered one to the International Space University in France. And then we have 2 that we toggle between Silicon Valley, NorCal Mars chapter, and the Habitat. This is me in the upper right-hand corner. I'm right here sitting on this ATV when I was part of Crew 97 as the teleroboticist. And the crews all have a different responsibility. So we have a commander, a crew commander, we have a geologist, a geophysicist, just different backgrounds and disciplines in science and engineering. Over here on the right, if my slide doesn't move, there we go. We're in Abu Dhabi looking at Sabkas. It's so amazing to be on these expeditions. You're in the middle of the desert, and all of a sudden there's water, there's a salt flat, and there's life in there. It's a highest saline environment, but there is life growing in there. It's just amazing to see. Bottom left, doing some analog simulations, testing out a new spacesuit design for human space exploration. This is in Australia. In the middle there, looking at 3.5 billion-year-old stromatolites. That was a very science-sensitive site. I was very fortunate to be able to be in the presence of those stromatolites, which were the dawn of life on our planet, that helped equalize our atmosphere. And then again, part of the convoy and reaching out to the local community as we do, doing education outreach about Mars and human space exploration. So how did I ever get inspired to forward humans to Mars? Well, it was just by ordinary human beings like you. And I just wanted to talk about how this all kind of got started, a little bit of history about how did humans get interested in humans to Mars anyway? Well, just like we celebrated last November of 2020, I was the chair of the National Astronomy Week. Mars was in opposition, so it was as closest in its orbit to Earth, and you could look outside your back garden, and hopefully you did, and took a view of Mars in. And Schiaparelli did this in 1877 at the Great Opposition. And what he thought he saw through his telescope was, he thought he saw, well, he described them as canali in Italian, which meant for him channels. But someone who was also interested in looking at Mars, Percival Lowell, misinterpreted this Italian word canali for canals. And he was so infatuated with this idea that canals are man-made, so these must be Martian-made, and perhaps there are living beings on Mars. And from that point forward, Percival Lowell lived the rest of his days looking for life on Mars. And then all these other authors and people and imaginations were sparked, and the world of Mars science fiction was born. And you can tell all the way up to 2011 in The Martian, and of course, I don't have The Expanse on there, and I'm sure I'm missing many others. The intrigue of life on Mars has never left us. And so here are some of the books that Percival Lowell wrote. He started in, I think, 1865 with The Evolution of Worlds. And what that brought to us was the plurality of worlds, was this idea to humanity that, wow, we're not the only possible life or the only world or the only planet. There could be other worlds out there, and maybe they have life too. And as you can see, he went on to write more and more books about Mars as the abode of life, and Mars and its canals made by Martians, and more on Mars. And there we go. And of course, as we got into the 50s, 1957, Russia did their very successful orbit around the planet, our planet Earth. And that was the first time we'd ever orbited an object around Earth. And of course, we know that kind of kicked off the space race, but it was scary and it was exciting. And they had a little beep sound that they could hear. And so that was sent around the world, and people were inspired by that and scared a little bit, but it started off the space race and this idea of, if we could put an object in orbit around the Earth, what else could we put in orbit around another planet? And before we go there, one other thing that happened after 1957, of course, it sparked then, human space exploration. In 1969, not only were we going to the moon at that time, we were also doing concurrent flybys of Mars with the Mariner mission. So there were 3 sets of Mariner missions in 1964, 1969, when we were headed to the moon, and in 1971. And that picture in the upper left-hand corner is actually an image from Mariner 4 of Mars, and it was happening when we were on the moon. And that's a picture of one of the Mariner flybys. Okay, satellites. And then in 1976, 1976 is when we finally landed on Mars. So we had a lander land, a robot. We sent a robot, the Viking missions to Mars, and then it sent pictures back. So from this sort of, evolution of looking through a telescope when Mars is close to Earth, and we can see maybe some more distinction on Mars, and then imagining that maybe, or misinterpreting a word, thinking it's life on Mars, to orbiting another planet and then landing on another planet. people just kept getting more curious and thinking about what can we do next. So we realized we could orbit the Earth. We realized that humans could orbit the Earth. That was part of the Mercury, Gemini, and Apollo human space missions. Then we landed on the moon in 1969. And of course, there were flybys of Mars that sent back images. So we got both images with humans on another object, and we got images via a robot on another object. And of course, we landed something successfully on another object, which was just amazing in 1976. So naturally, you want to think, what's next? Can we land humans on Mars, since we got them on the moon? And these individuals here were students in the late 70s and the 80s. They were graduate students. Dr. McKay here, holding a Mars globe, was my supervisor at NASA, and he was finishing up his PhD. And they really wanted to push this humans to Mars idea. And of course, they wanted to learn more about it and bring in other scientists and engineers and have discussions and start to actually kind of devise a plan about what can we do and what do we know and what do we need to know before we get to Mars. So they started something at the University of Colorado at Boulder called the Case for Mars conferences, and they happened every 3 years from 1981. And it inspired Dr. Robert Zubrin. Well, he was an engineer at Martin Marietta, and before that, he was a science teacher. So he was inspired by this space race to go into engineering, and he's a nuclear physicist. And he attended these conferences, and he realized that this Case for Mars papers that happened every 3 years. He had this idea. He was at Martin Marietta at the time, which became Lockheed Martin, and he decided to make it the Case for Mars. And I didn't introduce them. So Dr. Penny Boston, these were the three of them, except for Dr. Zubrin, were all students at the University of Colorado Boulder, who are now NASA planetary scientists. So Dr. Penny Boston, Dr. Robert Zubrin, Dr. Chris McKay, and Dr. Carol Stoker. Dr. McKay and Dr. Stoker are fantastic, and of course all of them are, but I got to go on an expedition in Australia with both of them, and that was just phenomenal to be out there looking at 3.5 billion-year-old stromatolites. So these are some of the publications from those meetings, those Case for Mars papers, which they were published by the American Astronautical Society, and you can get them online to purchase them yourself if you wanted to. So I thought I would show them, but I don't think the Astronautical Society sells them anymore. So they might be more expensive than they originally were. And here's that, the epitome of the Case for Mars from Dr. Zubrin. It's on its 25th anniversary. And if you want to know more about those individuals that were at the University of Colorado at Boulder, there was a movie made about them in 2007. And they were termed the Mars Underground because they were doing this as students and having these conferences on their own. And that Mars Underground spawned the Case for Mars, and of course, Mars Direct, which is what Dr. Zubrin published in 1990, or wrote up in 1990. It was a response to how to get humans to Mars faster and less expensive based on the technology that we already had from the Apollo missions. As an example, the Saturn V heavy lift rocket, and I apologize, I meant to get an image of that. But essentially would use heavy lift technology, what we already had been tried and true used for the Apollo missions to get humans to the moon. Here's a very simplified and inexpensive way to get humans to the moon. You send a crew the first year, sorry, not a crew, you send a vehicle the first year that's going to create fuel and oxygen and water on the surface. And so that when you do send a crew the next 2 years, or year 3, then there's already fuel, water, and oxygen waiting for them when they arrive. And then that just repeats every 2 years. But NASA had some critiques for that plan. So they decided to not do 1 launch a year, but do 3 launches a year. And they also wanted a Mars ascent vehicle. So they did land a HAB, uncrewed, I'd say. So no people on board first, right? And it sits there and waits for them. They also land a Mars ascent vehicle that's there, that's probably creating fuel and oxygen and water. So all the things that they need. Oh, and one thing I left out, so important about Mars Direct, is that basically, you know, to get off of this planet, you need to escape Earth's gravity. And as Dr. Zubrin always tells me, all we just need to do is lift and throw. So in order to do that and take everything that you need to look at your mass. How much mass are you taking? And of course, hydrogen was the basis of fuel. And it weighed a lot. So he said, bring a little bit of hydrogen. And when you get to the planet, you can create it there in situ, which means kind of living off the land, using the resources on Mars to create more fuel, which is why I meant when one of these vehicles lands on Mars, it has a machine on that starts changing some of the atmosphere into fuel, oxygen, and water using that little bit of hydrogen. And so this was NASA's semi-direct concept to get humans to Mars, a lot more robust, a lot more safety into it because it had redundancies in to make sure that if there were any problems, there was always a second backup system for humans to get to be able to leave Mars. And they would never do a one-way mission to Mars. So NASA would always want a way to get humans back to Earth. So who will get us to Mars? Well, you will. What will the first Martians be like? Well, initially, we're going to be looking for scientists and engineers, good STEM backgrounds who can lay a really good foundation. Material scientists, chemists, geologists, biologists, very similar to some of the crews that we have coming out to our HABs, and I'll talk about those in a second, with those backgrounds simulating starting a settlement on Mars. You'd have to be really good at teamwork. I have been on crews or living in these small environments, and you really need to make sure you get along and you work together. I like Scott Kelly's teamwork makes the dream work. People who love exploring, people who are problem solvers, and psychologically robust. And then also you're going to have to get used to automation and robotics and working amongst them. Let's see, I'll show you more about that in a little bit, but this is where Mars Society began in 1998. When we were done discussing how to get to Mars, we now wanted to put it into practice. And, you know, we've gone through life, at least I have for the last 20 years, knowing that there's only a few astronauts out there. And so this kind of gives everyone a little bit of a experience on their own to try it out for themselves. What would it be like being an astronaut or a crew member on a mission to Mars? So we had our first HAB delivered by helicopter in the Devon Island in the high Arctic in 2001. And I wanted to show that, you know, it does sound sometimes a long time ago, it was difficult to talk about humans to Mars, or it was difficult to understand, why are you pretending to live on Mars out in these habitats? Well, it's actually very scientific, and it was something that the astronauts, before they did their science on the moon, they would simulate doing it on Earth. And so that's exactly what we were doing. Before we go to Mars and live there, we want to simulate what it is, looking at human factors. Is it easy to grip a tool when you're in a suit? How heavy is your pack? Of course, you can't simulate everything, gravity and pressure and all that stuff, but you can do your best and get better design of tools when you're in a simulation suit. They were testing the buggies and mostly testing those tools to see how easy it was for them to use them, because when you're on the moon, at least for them, it was a sixth gravity of Earth. They had to get used to it. Their suits were pressurized. It was difficult for them to bend over and get back up. So they really had to make sure they were able to use those tools. Going back to the Mars Societies, here is our second HAB in Utah called the Mars Desert Research Station, MDRS. And it used to situate a crew of 6. I think now we can accommodate more, but here we have a crew of 6 is what we would expect to head to Mars. And they would live, it's a 2.5 story, 8-meter diameter capsule. And I can show you the inside of that. So it kind of had everything that you sort of needed, you know, as a human being: a toilet, a shower, 2 engineering airlocks. It had a lab, a science lab, an EVA. EVA stands for extravehicular activity. So a prep room, that's where all the helmets, the oxygen packs, your simulation suits were stored. And then crew quarters up on the top. So crew, there should be rooms for 6 there. And they're very narrow and small, but you appreciate your private space when you're in a small space like that with 5 other people. And then there's a kitchen, a dining area, and workstations, because when I was a crew member at MDRS, and here are some crew members at FMARS in the Arctic, going on an EVA themselves in their sim suits. And those are all handmade, our sim suits. We put them together with ready materials off the shelf. We have one of our chapters in NorCal who redoes them for us now and again when they start to run down. But you have to practice everything. Can you do the research that you need to do? Some of these were geophysicists. We had astronomers. We had geologists and biologists all coming out, simulating and doing field science under simulation. Here's some more pictures. We're also in an international organization, so we have people from all over the world. We've had over 200 crews come out and visit our habitats. You can see some of them even create their own suits. And they like to kind of come out and have their own color representation. We do have lots of different facilities, and we have evolved. So initially, of course, it was just HABs in these 2 different places on the Earth. And we chose a very geologically significant area similar to Mars as we could get. And we have evolved to having a solar array. We have astronomy dome. We have a science dome. We have an engineering hab. We had vehicles, ATVs, and we have a solar observatory. We have a green hab, gray water system. We had a full kitted out science area in the science dome with a I can't even remember the name of it. The exhaust. A fume hood, thank you, and some microscopes and everything you would need that you would normally do to do your science experiment in the lab. We try to get that equipment out to the hab for anyone who's wanting to do some research out there. And you can see there's 2 observatories. One of those was actually donated to us by Elon Musk, which is now our solar observatory, and the other ones are a remote observatory. And we put the tunnels in so that people didn't have to get in and out of sim, so they could still be in sim from the hab and move through a tunnel as if it was pressurized without having to put back their sim. Because the rule was, if you're simulating living on Mars, anytime you exited the hab, you were full on suit gear in sim. And it's pretty popular coming out. So that very terrible picture, sorry, it's not very clear up here, but this is Ozzy Osbourne and his son, Jack Osbourne. They've come out to check out the Mars Desert Research Station, and hopefully you recognize Brian Cox. He's been out and did a BBC show at the Mars Desert Research Station in Utah as well. We have all kinds of challenges. Not only do we host crews to come out and do their research, but we also have rover challenges. We have Mars City Design contests, and we think that these contests and challenges really help people imagine a life on Mars. And also we're very action oriented, so it gets people to work towards living and working on Mars. And it makes helps people imagine this and innovate for it. And so we have all these young students come out. We have a rover challenge in Europe, so the European Rover Challenge. We have a University Rover Challenge in Utah. We have one in India and in Canada, and we even had one in the UK in Manchester in 2016. And Tim Peake's been out to the European Rover Challenge in Poland. Since we have had these habitats since 2001, they have expanded. They've become very popular. So again, Mars Underground is from the late 70s, early 80s. The Case for Mars happened through the 90s. Then the Case for Mars book was in 1996. Mars Society was born in 1998. We had our habitat in 2001. I think Mars 500 was probably maybe a new one there, but the IBMP, they've been around since the late 50s for Russia. It's called the I'm going to have a hard time remembering this. It's biomedical problems. I can remember that part, IBMP. But we had food studies by Cornell, and we had some biologists from University of Hawaii. and they had been working with us for several years at the Mars Desert Research Station. Those two went off and got funding, fantastic funding from NASA to build HI-SEAS. So HI-SEAS is an offshoot, not really connected to us anymore, but they had been working with us, and they have a very successful mission in Hawaii called HI-SEAS in 2013. Lunaris is another sim down here in Poland. We have VMARS is in Israel, that's over here, bottom right. Oman is a fairly new simulation, Oman Mars. Mars Base 1 in China is this one in the upper right-hand corner that was originally made for a reality TV show in China. And now they're going to use it for, using it for tourists and for people who are curious to come out, like a museum, to come out and check it out. Oh, and this is HI-SEAS up here, and in the background is the Mars 500. But there's others that we don't have here, like Habitat Marte in Brazil, brand new last year in 2020, and Mongolia. So this one in China is in the Gobi Desert. Let me see if I can get back to it. Yeah, there we go. It's in the Gobi Desert, in this, like the southern Gobi Desert for China. And then Mars V is going to be in Mongolia in the northern Gobi Desert. So, and Mars V in Mongolia, they want to build a whole Mars city. They don't just want to stop with the habitat and a few facilities. They want it to be a really huge interactive Mars base. And then, with architecture and innovation and having to be comfortable around robotics and automation, this great contest that NASA had for 3D printing a habitat on Mars, and these were the winners. AI Space Factory printed a Mars habitat using simulant, a Martian simulant. So basically using in situ resource utilization, again, living off the land, using the resources available to you there on the planet. And then we're getting in a little bit into robotics, and I was there in Pasadena for their landing of Opportunity in 2004, and we had Stephen Squires come to our conferences, and I will never forget when he came to one of our conferences, and he let us know, because he knew we were very human smarts oriented, that he's created these rovers because to create a path for humans, and humans will follow the rovers. And so I thank Stephen Squires for that spirit and opportunity. We're on Mars for a long time and gave us a lot of data, found some signs of past water with the sphericals, I think they're called. That could be the Martian blueberries, hematite, that are found in around water. So those are found. Let's see, we have access to space. So this is, we're getting into a little bit of a political part of space in the United States, of course. 1980s was Clinton, and the commercial space wasn't really common. I mean, it was for, of course, NASA used Boeing and Lockheed Martin or Martin Marietta and other private space to do some of their projects, but it was growing, and NASA wasn't really interested in, of course, letting private space take on human space exploration. It needed a lot more encouraging and development. So lots of these acts started coming out in the United States. The Commercial Space Act of 1998 encouraged development. So little by little, they were trying to get NASA and other government heads to accept this idea of private space in the United States. You see, in 2004, they had to force NASA's hand to legalize private space flight. Now, space flight is a really sensitive subject for NASA, right? They are all about safety and human space flight. And this was really difficult for them to let it go over to a private entity. But of course, as we know now, they have. Augustine Commission started in 2009. That was under the Obama administration to talk about human space flight. I've had the privilege to attend one of those meetings with Dr. Zubrin. Basically, it was just a lot of talk, and we weren't going anywhere for several presidential administrations in the United States. The Space Act of 2015 finally allowed US citizens to start private businesses and exploit space resources. That was really about asteroids. That was also around the Obama administration. But of course, no one ever went to an asteroid, because as soon as the next president came in, that program was cut and changed. So you can sort of see a pattern here with every president that came in, the space program was changed. And so I was lobbying in space with the Space Exploration Alliance, working for the Moon, Mars, and beyond. Of course, I wanted to go to Mars. That was during the Bush administration, and doing anything I can to help forward private space in the United States, to help forward human space exploration. And of course, we have JFK, thankfully, who pushed humanity towards the moon. Right now, Blue Origin and Elon Musk are pushing towards, Blue Origin suborbital flights, but they're also interested in getting us to Mars. And as you may know already, Elon Musk is very much interested in getting humans to Mars in the very recent future. And one of the things, he came to our conference last year. We did it online because of the pandemic. We had over 60,000 people viewing us at the time. And it was quite interesting when him and Dr. Zubin were saying, where there's a will, there's a way. And Dr. Zubin said, Mars Society will provide the will. And Elon said, SpaceX will provide the way. I just want to touch really quickly, and I see because we had some technical difficulties, I don't have very much more time. The Curiosity rover was a fantastic field science, geology field science rover. It was checking for radiation at lower levels towards the surface for humans. I don't think it got good results there. It probably got good results, but not for humans anyway. So there's still some work to be done to protect humans on the surface of Mars with radiation. I understand that. There was evidence found for liquid water from this ancient stream bed on Mars, and it also found some of the important chemistry for life on Mars as it did its analysis with its ChemCam. It found sulfur, nitrogen, oxygen, phosphorus, and carbon. So it had a really good run on Mars. This isn't really, they're getting the pulse of Mars here. They're trying to find how dynamic it is, its core anymore. What's the heat pathway like on Mars, but also looking at, its evolution as a planet stopped at some point. Can that give us any clue on Mars's evolution as a terrestrial planet? So I just thought I'd pull it in there because it is an important and significant, mission on Mars. So studying the interior of the planet. And it was so cool because we got to hear a Mars quake. So that was fantastic. And another important, looking for water. Not only are we looking for life, but we're also looking for water for future humans on Mars. So this was the Mars Express in 2018, which found liquid water 1.5 kilometers below the surface of the South Pole. And then back to private space. And I guess maybe that's kind of what I've worked really hard in trying to get past government officials and NASA. I've had meetings with directors of the Space and Technology and the House of Representatives committee, arguing over the importance of private space since 2004. I lobbied in 2004, 2006, and 2009 for some of the human space programs and for private space. So Jeff Bezos started Blue Origin 2000, Elon Musk 2 years later in 2002, Virgin Galactic still working on their suborbital flight since 2004, Lockheed and Boeing got together for the United Launch Alliance in 2005. So you're seeing all these people working together, collaborating, trying to push human interest in space, taking suborbital flights. The idea of that is if more people go up and see the curvature of the Earth, they would understand how, perhaps they would see how beautiful it is to explore and how beyond our planet, there's much more to explore beyond Earth's orbit. Let's see, 2014, NASA finally announces that they're going to use Boeing and SpaceX to take humans to the International Space Station. And 2018, private company Moon Express was given permission to land on the moon. So this is all very difficult for NASA to let go of and allow, but we're never going to get there with private space if we don't give them these sort of freedoms. And of course, Rocket Lab in New Zealand, which is an American company in New Zealand doing launches for satellites, and Link Space in China. So this is an image of Link Space rocket launch. And here are the astronauts that NASA gave to SpaceX and Boeing in 2018. They knew they were going to get them since 2014, I believe. And finally, and as we know, they successfully, Doug and Bob successfully made it to the ISS last year, which was So exciting to have during the pandemic, something to look forward to. And I just wanted to show that private space is increasing. This is probably an old slide from maybe 1 or 2 years ago, and I'm sure it has grown. And China is definitely ramping up on space exploration. So I wanted to talk a little bit more about China and what they've been doing. Their first rocket launch in 1970, their first astronaut in 2003, and then look how much they've done in the early 2000s. 2007, they went to the moon, they landed on the moon. 2012 isn't on there, but that's when they had their first female Chinese astronauts. They did their first moon landing in 2013. 2007, they orbited the moon, apologies. 2019, the first landing on the far side of the moon, which is just amazing that they did that. They did I have a picture of that, so I'll talk about it in a second. 2011, they created their own space lab that was in orbit, and they had astronauts on it for a while. And they want to build their own space station and larger. So that's, I think her name is Liu Wang. She's the first female Chinese astronaut. It's an illustrator image of their space lab that they want to, space station that they want to build, and the Long March rocket system that they use. That's one of their rockets. And this is the Chang'e 4, which I believe landed on the far side of the moon. Fantastic, amazing. It's a lander with a rover, and they also put a satellite in Lagrange point 2, so that because it's on the far side of the moon, which we don't see it from Earth because the moon is tidally locked. So it's always behind us. And so because they put a satellite in Lagrange point 2 behind it, that satellite has a clear line of sight to Earth, so that the rover and the lander can communicate with Earth anytime it needs to. Just amazing. And they also grew life temporarily on the moon. But it was a really great experiment. And they are just knocking it out of the park lately and ramping up in China. When I was there in 2019 doing a Mars camp. And here they have a mission which is going to be landing February 10th, very soon from today, Tianwen-1, which is their Mars probe, and it's going to do a lot of geology, looking for life, studying the ionosphere and the electromagnetic waves and gravity on Mars. Okay, Mars Hope with the United Arab Emirates, looking at Martian atmosphere, looking at Mars has a very thin atmosphere, it's losing its atmosphere, so it wants to study how this energy moves, looking at neutral atoms of oxygen and hydrogen, because they think that's better understand the role of this erosion of the atmosphere. So it's really exciting because I don't know how much data we have on this. So it's really great that they're going to be getting this, and hopefully it's collaborative where they share their data about what they learn about the atmosphere of Mars. Landing on February 9th. So I think this is the first landing we'll get for the Mars missions coming up. February 9th is first, China's second, and then Perseverance, which is the same chassis that used for Curiosity, but much more robust. I think it's got like 23 cameras that can look farther and higher resolution, seeking signs of life. So this one and China's lander rover is also looking for life on Mars. This one's going to cache it with Sherlock at the front here, and this is Sherlock here, and Watson is going to be taking pictures of those samples that it picks up from certain spots on Mars and caching them on the surface for a later return. But another interesting instrument that's on the Perseverance rover is called MOXIE, and it's an oxygen in situ experiment, Mars oxygen in situ experiment. So it wants to use some of the the carbon dioxide in the Martian atmosphere and see if it can create oxygen. So this goes back to Mars Direct, and when we land on Mars, a machine that can use a little bit of hydrogen, create fuel, oxygen, water. This one wants to see if it can use some of the atmosphere in Mars, CO2, and liberate some of that oxygen for future crews on Mars. So this is testing some of that instrumentation on the planet for future human settlement, or future human exploration. And of course, it's got a Mars helicopter, which is so exciting to see it hopping around. It's just to see how well can it how well can it stay in the atmosphere of Mars, or because it doesn't have very much pressure. Flight isn't really understood well on Mars, so this will be a really great experiment, and it's landing February 18th. And of course, Rosalind Franklin has been delayed, something to look forward to in 22, and landing in June of 23. Also looking for signs of life. I don't think I have very much time. Louise, do I want to check in with you?
Sorry, Lucinda. It's 1:45.
Okay, maybe a couple more minutes.
Yeah.
Okay, thank you. So SpaceX started in 2002. Elon Musk has said he can get humans to Mars in 6 years. He just needs 2 years to test if he can get to Mars, and then send humans in 4 years. So he's confident that he'll have humans on Mars by 2026, which is very ambitious, even for a Mars enthusiast like me. But Mars Society has always advocated for humans to Mars in a decade, and that was because they got humans to the moon in 8 years and had the idea of going to Mars afterwards based on that technology. Is Dr. Zubrin's Mars Direct Plan, which we don't really have anymore. So this is why I have a difficulty with this timeline. But I do know that SpaceX, on all those fantastic engineers and scientists, are working really hard to build something. And it's absolutely beautiful. Starship, I did not see how Starship went yesterday, if they did a test launch. Yeah, the Starship is what I think is in Boca Chica. This is one of their booster rockets. So again, this will do the lift and throw, and it'll be throwing one of these starships out towards Mars. And what's so great about these booster rockets is that they're reusable. They will come back and land on Earth. And hopefully some of you out there have seen some of these landings. They've done 2 at a time as well. It's just remarkable. And this is to lower the cost of human space exploration as well. And just to give you an idea of the size, this is the booster with a Starship on top. Here's a lunar lander down here compared to what we had humans in on the moon. Here's what Elon expects to have landing on the surface of Mars. And this actually is the Saturn V. And this is where we used to put the crew right up here. Everything else was fuel just to get them off Earth. So a lot different in space on the craft than we've ever had before as well. And just some imaginative ideas of what it could look like on Mars, and perhaps what it would look like once we settle on Mars. And I know there's a lot of work to do, but I have seen so many inspired individuals from the chapters that we open all over the world who are so ready for something to look forward to in their future. And I just want to end with a couple of thoughts from Dr. Zubrin. If we can, we should not just bring life to Mars, but bring Mars to life. And he thinks we will, and so do I. My former supervisor at NASA thinks that life is the most beautiful thing he sees in the universe. And he says, go forth and spread life. Earth's gift to the universe is the gift of life. And I absolutely agree with Dr. McKay. And this is one of my favorite illustrations in 1888 about breaking free from the sky and looking beyond. And this is a newer version from the 21st century from Melgredi, who is telling humans to reach beyond the stars and explore. And I want to just quickly 2 more things, Louise. One is, if you're a teacher and you're interested in doing some field science with scientists so that you can share this with your classroom, this is coming up in India, in Ladakh in 2021. You can apply by February 15th. If you go to that URL down there, acoea.com/RSP, and you could apply to be part of a 3-week expedition doing some Mars analog research, some astrobiology research, and they will pay for you to do that as long as you qualify. And then coming up June 8th through 11th, this is the Institutions of Extraterrestrial Liberty. This is by Professor Charles Cockell at the University of Edinburgh, who has been a longtime Mars Society member. And Dr. Robert Zubrin will be speaking. He's one of the keynote lecturers there. And so that's something to look forward to this June. I believe it's free, and you can go to astrobiology.ac.uk or Eventbrite, look up the Institutions of Extraterrestrial Liberty if you'd like to join in. And I think that's all I have. Thank you so much. If you have any questions, we just have 10 minutes.
Okay, we do. Thank you very much, Lucinda. That was amazing. And it's a very popular subject. There are lots of questions. So yeah, I'm going to start with this one because it's quite interesting, sort of following on from your talk, that in the age of robotics and AI and machine learning, why do we want to send humans to Mars? Why wouldn't rovers and robotic arms be less expensive, more efficient and safer?
Really good question. The three reasons we want to go to Mars is for the science, for the challenge, and for the future. As a geologist, as a field scientist, I would love to go there and do my own, as a geologist, I can see what rocks I want and what areas I want to look to a lot quicker than the rovers. One thing we don't realize is how slow those rovers are. They're remotely driven, from JPL, and then they have to send the code. That code takes, depending on where Mars is in orbit, it might take a long 20 minutes. And then when the rover gets that information, it's going to move very, very slowly because then it has to send the signal back to let know JPL that it's not in danger. That's a lot of time wasted. And as a human, I could do that a lot faster on the surface of Mars myself. For the challenge, one thing that I've devoted my life to is the growth of humanity. And the only way I can grow myself is if I challenge myself. And I think through the challenges of solving these problems like radiation exposure, transport to Mars, etc. Those are the ways we're going to innovate and grow. And all those innovations are going to benefit us here on Earth. Absolutely. And I want to say this as well for our future, for our own existential risk. One of the thoughts I had when this pandemic took place, other than thinking of my own demise or my family and friends, was I wish we had humans on Mars. I wish we had someone already out there in case something happened to us, human existence would carry on without us. So that was something that comes from the future.
That's a good point. Thank you. Francisco Diego is making the point that space exploration should be internationally regulated. Otherwise, it will bring chaos, competition and conflict. So no single nation should have the right to establish their own laws. Do you have any comments on that?
Yeah, I think as a COSPAR, I think they do the international, I hope I'm right, the rules of space and space exploration for the planet, for how we go forth. And absolutely agree with you. We should all work together. We have planetary protection, that whole idea. The one thing about Mars, though, is what if we don't find life on Mars? And that's actually something I'm kind of looking forward to. If we don't find life on Mars, then maybe people who are worried about protecting a planet wouldn't mind if we put life on Mars and made Mars come alive. Because that idea of planetary protection is, not disturbing microbial life that might already be on there. But that life might actually be already connected to us or might already exist here on Earth. There's so many unanswered questions. And so that's what's so exciting about some of the data we get back from some of these missions.
Yeah. Following on from that, in a way, Clara Skews, who said, thank you for your talk. Why is there such a push for private companies to be leading the mission to Mars? In the short term, they will get things going, but surely they will introduce more monopolization and secrecy later on. Is it impossible without sort of private companies?
So, well, I think it's interesting. You can think that way. Another way is to think of them working together and having the freedom to collaborate. And even with, I don't know if bringing in China was kind of what spawned that idea for you. But I found working in China and with China very open, very eager and interested in space exploration and working together. I work with them ongoing from here, from the UK. But I think it's also going to help innovate. The two main reasons are costs. It'll reduce costs for doing space exploration. NASA no longer wants to do all that back end work. They want to be a customer and go buy it from someone who already does it. So that's why they are now wanting more private space, because then they can pick and choose and get that mission done with someone else doing all the hard work. And innovation, it's just going to spawn innovation, more ideas. If it frees up anyone in their home to start a private space company if they have the gumption to do so, the money to do so, and the connections to get the people to help them innovate whatever idea they have to solve a problem for human space exploration. It's only going to accelerate human space exploration.
Thank you. Terry Mosley is asking a question. This may relate to some of the things that you've looked at in simulation. The first astronauts to land on Mars will be severely debilitated after their long journey. There will be no medical team there to look after them. And even with lower Martian gravity, it will be very stressful and difficult. How will they cope in the first few days?
Well, these are things that the Institute of Biomedical Problems in Russia are looking at and doing. We've also had medical crews do crew rotations at the Mars Desert Research Station, simulating these sorts of things, any sort of medical emergencies or recuperation. So they are simulating these. I haven't looked at the research specifically, but I'm sure they're coming up with some solutions to this.
Okay, and this is one, yeah, this is quite interesting to me as well. So Stephen King's asked, which is easier, a Mars base or a lunar one? Which makes more sense as an engineering strategy for, it said manned means human, expansion into the solar system?
I mean, there's a whole, there's a lot more autonomy that's going to have to happen in Mars, obviously, because it's 2 days to the moon, 6 to 8 months to Mars, and you're going to have to wait a year and a half before you could come back. So to Earth. So from that point of view, it is easier to practice something on the moon, but it's no testing ground for Mars. There's no atmosphere on the moon. The gravity's less on the moon than it is on Mars. The temperature difference is huge on the moon compared to Mars. So maybe for engineering things, do that on the moon. But I don't think it should stop us just because it's closer. I hope that answers your question.
Yeah, no, I agree. But it's interesting that people have to think either about the moon or the Mars when really it's both. Make use of one to get to the other. And
that's right. Yeah. So,
okay.
Any other?
Yes, gosh, there's so many, sorry. Oh, someone's just asked, can you give us the details of the Edinburgh event again?
Yeah, there we go. Take a screenshot. Okay. So Charles Coquel's written lots of research papers. Some of them I've had to read myself, which are they're fantastic. But he's talking about rights for microbial life, and they're going to talk about the freedoms or the rights of microbial life. This is very similar to a Mars Society conference where we talk about all aspects: governance, religion, what kind of activities you're going to have on Mars. We do art and poetry and architecture, all types of discussion, which just like starting any sort of community, you would have to discuss these things.
Yes, well, actually, it's quite interesting because quite a few people have asked in one way or another, how do they get involved in these types of projects? What does it take? Where do they start? So
there's depending on where you are around the world, but you can always go to info@marssociety.org. You can email me. I'm at Lucinda@marssociety.org if you have any questions. We have chapters all over the world. We have them in Africa. I have them in Kuwait. I've opened one last year. We have them in China, obviously now. We have them all over the United States. We have one in the UK. We have Mars Society UK here, which is a fantastic bunch of physicists, engineers and scientists from Reaction Engines Limited. They're a great bunch. And they're looking at sustainability on Mars and sustainability on Earth, and looking at hydroponics and things like that. So they're really interested in that type of research here.
Okay. Is the end goal of all this is the question from Lester Shaw, is the end goal necessarily going to be the terraforming of Mars?
I didn't put those. I normally do talk about, that's what some of the things I worked on with Dr. McKay. But yeah, if you want a human settlement, you want to make it easy for humans eventually. So how do we warm up the planet? Something we can do really easily here on Earth. We seem to be really good at warming up our planet, but maybe we can use it for good on another planet. Is there enough CO2 to do that? You know, those are lots of questions that are still unanswered. But you would want humans, you want to increase the pressure a little bit more on Mars so that humans can walk about a little bit more easier, maybe in a pressure suit and not in a full-on pressurized astronaut suit. And then maybe they just need a little bit of oxygen if you've changed a little bit of the air on Mars too. So.
Okay, I'm going to ask one last question because we're going to be out of time. James Wordsworth, if there is life discovered on Mars, would it be likely to inhibit future human missions?
I hope not. But I think you're probably right. With planetary protection, I think the idea would be to find out, which is something also Dr. McKay was always wanting to know, if we found life on Mars, is it similar to our chemistry, or is it a completely different branch of life, an alien life to us? And I think that would have to be the question. If it's similar to us, I would imagine there should be no problem with us going over there because we're related. But if it's not similar to us, that might be a more difficult question for disturbing a life form like that on another planet.
Okay, thank you, Lucinda. I'm going to have to leave it there, and I'm going to hand back to Annie now.
Thank you so much. Thank you, everyone.
Oh, thanks, Louise. And thank you, Lucinda. I think you'll all agree that that was an incredible talk, which we could have continued for much longer than the allotted hour. Just a little bit of housekeeping. The next public lecture will take place on the 16th of February. Lucy Green will be talking about the sun and the observations and discoveries made whilst observing solar eclipses. Details and tickets will be available on the RAS website. Thanks very much. Bye-bye.